I'm delighted to welcome Matías Taucare to the podcast. Matías is a professor at the Geology Department of Geology at the University of Chile in Santiago. And Matías has been working on water resource issues in Chile for many years. And we met a couple of years ago in Sao Paulo at the Groundwater Congress. And I was very impressed with his work. Today, Matías is going to give us some background information on Chile because we've never had anybody talk about Chile before on the podcast. And then we will discuss water resource issues related to agriculture, urban water use, and climate. So thank you so much, Matías, for joining me today.
Well, Bridget, thank you to you for the invitation. I am very happy to share the time with you in this podcast. So let's go with this conversation.
Right. So, Matías, as I mentioned, we've not had anybody talk about Chile before, and it would be nice to give the listeners some background information on Chile. I mean, you look at the map, you see it's more than 4,000 kilometers long from north to south, and I looked up, population of about 18.5 million. That's about half of the population in Texas. And then the area is similar to Texas, 750,000 square kilometers. Texas is about 700,000. So maybe you can describe, the physiography of the country, some of the political divisions and that sort of thing, Matías.
Well, yes, Chile is a very long country, and at the same time, it's very narrow. Indeed, you say, well, the longitude is 4,200 kilometers, but in width is 200 kilometers around. So it's very narrow. Chile is a country that shares the boundary with Peru, Bolivia, and Argentina in the southern part of South America and the southwestern part. Well, it has a population of about 20 million people, and to the west is bordered by the Pacific Ocean, and to the east, the limit is the Andean Cordillera, that I will talk about more about the Andean Cordillera because it's very important for Chile, the geomorphology of this mountain belt. And this, economically, Chile, well, is a country that is strongly about the mining and the agriculture, especially mining. We are very famous because of our copper deposit. And now for the lithium deposit related to the salt flat located in the north part of Chile, in the Atacama Desert. But also Chile is famous in the agricultural things about the wine, the vineyards and the grape. And this is the most important things about the economic part of Chile.
Right. Well, thanks. So, you're on the West Coast, and so a lot of your physiography is sort of like California. You have the Andes and they have the Sierras, and then you also got a coastal range, and similar to the coastal range in California. And so the Andes, I see goes up to 4 to 7 kilometers elevation, but the coastal range is about 2 kilometers. And so in between those two mountain ranges, then you have the Central Depression where Santiago is, and it's similar to the Central Valley in California. But your basin thickness, I think, is not as thick as the Central Valley. It's maybe 200 or 300 meters thick. And you live in the capital, right, in Santiago, that's a lot of the population are located there, about 7 million people, is it, or?
Yes, around 7 million people. Well, yes, I am living here in Santiago, but I am from the north of Chile. I am from Iquique, that is close to Peru, located in the Atacama Desert. It's a coastal city that, well, after that I study in Antofagasta, then I come here to Santiago to do my PhD and then to work here. But well, yes, for Chile, the Andean Cordillera, the physiography is very relevant. Usually, as geographic name, the Andean Cordillera is just the highest part. But from a geological point of view, the Andean Cordillera comes from the Pacific Ocean and arrives to the east part to Argentina. And then you can subdivide as a general view, as you well said, as coastal range to the west. Then you have in the middle a sedimentary basin that is called Central Depression. And then you have the principal cordillera, where is located all the volcanoes and the main porphyry copper deposit, and also the salar with the lithium deposit. This is the general physiography because you have some particularity. Well, Chile is very long. So in the middle, you can find some parts without this central valley and other particularities.
Right, right. And you mentioned you're from the north, the Atacama Desert region, and so you go from desert in the north, and Santiago, where you're now, is in central Chile and maybe Mediterranean type climate with wet austral winters and dry summers, and then for the south, then you've got the fjords and the glaciers. So you got the country's so long, you experience a lot of different climates as you go from north to south.
Yes, indeed. Well, Chile cover from the 18 degree of latitude to 56 around. So we have a lot of kind of climate. But yes, if we talk about the general terms, the north area of Chile is characterized by the hyper-arid climate. That, well, it's the Atacama Desert, the most driest desert in the planet. Then, well, in the Atacama Desert, you can have around 10 millimeters per year as an average of precipitation in the Central Valley or in the coastal area. And you can reach around 70 to 100 millimeters a year in the highest part of the Andes because of the orographic effect of precipitation. Particularly, the north is a little bit different in kind of climate seasons from the rest of Chile. The rest of Chile, you have the rain during the austral winter, and then you have an austral summer very dry. But in the north of Chile, we have the austral summer very humid because we receive the humid vapor coming from the Amazonian basin and from Atlantic influence. So it's a little bit different. While during winter, despite that it's a little bit cold, we don't have too much precipitation. Then when you go to the central area of Chile, you have, yes, a Mediterranean or semi-arid climate with around of 300 millimeters per year. It's depend, obviously, the altitude where you find. And well, here is Santiago, the capital city. Here the main activity is the agriculture and also mining. And then if we go to the southern part of Chile, it is very humid. It is easy to reach 2,000 millimeters per year in some area like Valdivia, for example, that is a very touristy place. And obviously, you have glacier if you go to the fjords, and it's very beautiful. But we also have glaciers in the highest part of the Andes, in the central area of Chile, that feed all the rivers downstream that arrive to the Pacific Ocean. This is, in general terms, the geomorphology of Chile, and well, related with also with the climate.
Right, right. So that's great. And you mentioned how important mining is in Chile, and I was just looking up some stuff and, maybe some data from 2022 and your exports, and it seemed like mining accounted for maybe 75% of the total exports. It was about 100 billion in 2022, and the source I was looking at mostly to China, and 75 billion was coming from the mining industry. And, you've had a very long history of mining silver, nitrate, and copper and lithium and rare earths. And so that has kind of evolved over time, Matthias. Can you just describe that a little bit? Where are most of the mines, and, what are the minerals that are being extracted?
Well, yes, we have a very long history about mining. At the beginning, when the Spanish arrived to Chile, they explored silver and in some parts gold that are most concentrated from central Chile to the north. Then, during the 80s, we have an explosion about the nitrate that is called caliche here, that were used for fertilizers and explosive, until the German invent the how can I say the
Synthetic nitrate, I think. Yeah.
exactly.
Nitrate.
Yes. Yeah. After this, Chile started to explode the copper because, we have different kind of copper deposit. You can find porphyry coppers in the principal cordillera. You can find the iron oxide copper gold deposit in the coastal cordillera, but also you can find strata bound copper deposit. So we have different type of mining here in Chile, and that is why Chile is very famous about the copper exportation around the world, for China, for United States. And now the last years, with this energy transition, the lithium in Argentina and in the southern west part of Bolivia. Particularly in Chile, the Atacama Salt Flat contain brines with almost 2,000 ppm of lithium. So we have a brines with high concentration of lithium. And this is why some enterprises start to explore this mineral here. And we have other sellers like La Isla, for example, that have 1,000 milligrams per liter of lithium, for example. Yes, it is the new kind of mining that is starting in Chile, the lithium.
Right. And I guess I saw the Salar de Atacama, so that's one of the large ones, I guess, in the Atacama Desert, the lithium mines.
Yes, indeed. Well, the Atacama Salar, it is a very touristic place. So you have some dispute there about the people living there, about the tourists related to the mining extraction, because the Atacama, San Pedro de Atacama is a very touristic place and have a very fragile ecosystem there. So the first peoples living there, that the Atacamans, have some conflicts with the mining exploitation because, for extract lithium, you have to extract groundwater, and the level start to decrease, and also disconnect with the wetlands that the different animal or ecosystem depend. So it is a very important issue here in Chile, the environmental aspect.
Right. So you, when we met in Sao Paulo, you had a poster about the groundwater overexploitation in the Central Depression and very large depletion of groundwater. You know, you were reporting maybe 20 to 40 meters over the 10-year time periods. So that was really interesting. And you have a nice paper describing that now. And also, Chile has been experiencing what they call a mega drought or hyper drought since 2010. And so many people have been attributing the groundwater depletion to the drought. But I think your work has provided much longer term context for what has been going on. Can you describe that a little bit, Matías?
Yes, well, the central Chile area, as I said previously, is is the area that concentrates most of Chilean population and also the most of economic activities. So water is very important, either for agriculture, either for mining or different economic activity, and also for drinking water. The thing is that since 2010, Central Chile area is affected by a sequence of dry years that is called megadrought, and the last year the name changed to hyperdrought because it continues. And well, it is around 14 years of drought where the rain decreased 45% and up to 75% during 22-21. So it was a difficult times. The thing is that during the mega drought, since 2010, the rivers obviously start to decrease the flow rate. And the people start to use the groundwater to support all the activities. And well, when some people, especially the rural people start to see that their wells start to don't have water. The people say, "Oh, what happened?" And politicians say, "Well, it's the mega drought." But when we start to see the long-term data, we see that it's not only the mega drought, and our aquifer is overexploited since the 90s. So it is not so easy to say, oh, it is the mega drought. I think this is the easy way because, you can't control the climate, but you can control the exploitation of water. And this is a kind of problem in Chile because now we have problems with the groundwater depletion, and this start to trigger another kind of problems like the disconnection with ecosystems, for example, along rivers. In the coastal area, for example, but also the land subsidence that was reported in the north area of Santiago. So this is a long-term overexploitation that obviously during the mega drought it was exacerbated because people start to use more the groundwater. But at the same time, with the increase of temperature, we continue to have groundwater recharge by indirect recharge because of the glacier melt that continue feed the rivers, and then we have the indirect recharge. But the basins that don't have glacier are more affected. Indeed, La Ligua Basin, for example, in the north area of central Chile that don't have glaciers, have the water level fall around 50 meters during a period of 10 years. So you can calculate a depletion rate of 5 meters per year. That is too much, at least. I think that is too much if we compare
Right.
with another aquifers.
Yeah, and I was very impressed with your study, Matthias. I mean, you looked at water rights. A couple, 2 to 3,000 water rights, and the amount of water that was permitted to be used, and then you did detailed monitoring of groundwater levels. You looked at water table data, and then you used chemistry data. So it was a very nice analysis, and I like the fact that, it's very easy for us to say, oh, we have a drought, we're short of water, it must be just the drought, and we can't control anything. But I mean, Chile is known for having, probably one of the largest water markets in many regions, and since the 1981. And so the water rights are private property, and you have consumptive and water rights for irrigation and for cities, and also non-consumptive rights for hydropower. Can you describe a little bit, the water markets and the governance aspects of water resources?
Yes. Well, at the beginning, the water market start around 1980, around during the dictatorship. During this period, they start this new water code that legally regulate the water withdrawals in Chile and the water restriction. And yes, it is a kind of model where that depend of water allocation, but then is founded in the supply and demand law. So it's a water market. The thing is that at the beginning, all these water rights was free, and then the people start to sell these water rights. But for another point of view, when we have drought, well, the offer start to decrease. So the water right increase its price. So it's it's a water market. We can say that, and it is supported by the Dirección General de Agua, that is the Water Directorate of Chile. And well, we have now some restriction because the people see that in some part we don't have too much water, particularly during the mega drought. So some area have some restriction to give or to sell the water right, but this is from the last 3-4 years. But if we go before of that, now the people sell the water right, especially the rich people, and well, it generate a kind of disconnection between the rich people, the poor people, the people living in rural area, the people living in the urban area. We have this disparity. So this is what I can say. Now we have a new water code. I think that one of the most important change it was that with the first water code, all the water rights are forever, for forever. Now it will be evaluated if the water right can continue. But since 2022, but all previous water rights are allocated for always. So, well, this kind of system generate a high stress period in different basins, particularly in the north one, where we don't have too much recharge. So this is a difficult system.
Right.
That is what can I say.
Yeah. And you mentioned, Matthias, that Santiago is fed by surface water from reservoirs. So I assume those the reservoir storage decreased a lot, has been declining a lot during this mega drought. So has the capacity of the reservoirs that feed Santiago municipality, has that been decreasing a lot in recent years?
Yes, here in Santiago, we depend mostly of El Yeso Dam. That is a reservoir located in the middle of the principal cordillera. And we depend of that, but during the mega drought, the level decreased down to level I've never seen here in Santiago. So the drinking water and the water intended for agriculture or mining, etc., start to depend of for groundwater, particularly those extracted from the Central Valley aquifers, the alluvial aquifers. And yes, well, we have this very big dam, and is for the water qualities many very good. We have a sulfate calcium phases about the chemistry, and the quality is usually very good.
Right. Yeah, yeah. And your aquifer, I mean, the central depression, the aquifer there is maybe 200 or 300 meters thick. I mean, the Central Valley in California, I think maybe, I don't recall, but maybe over a kilometer thick or much thicker than that, but maybe the freshwater resource. So your aquifer, the central depression is not huge. It's not really that thick.
No, indeed, the Central Depression here in Santiago, for example, have some depot center with maximum thick of about 500 meters depth, but very local part. The average is around 300 meters depth. This
Right.
is the thickness of the Central
Yeah.
Valley aquifers.
And of course, a lot of the water, reading some of the reports, it goes towards agriculture and maybe accounting for 60%, 70% of the water use. But when I was looking at your export data, it seems like most of it is horticulture and maybe $20 billion. So maybe 20% of the total exports is horticultural products. You mentioned Chilean wine and avocados and all of these things that we all enjoy. So these are not annual crops, and these are trees, and so you can't just stop growing them during a drought. So I guess that's a big user of water.
Yes, this is why groundwater start to decrease too much, because here we have a lot of avocados. If you visit Chile and you go around from here the Central Valley to the coastal, for example, you can see all the hills with avocados tree. And you say, but well, it is difficult to have this kind of tree that need a lot of water. But we have avocados here and need water. And if during mega drought we didn't have too much rain, we didn't have too much superficial water, groundwater support all of this kind of agriculture. And yes, you can see all of the hills with avocados tree. It is very impressive. And when you start to see the Google Earth, for example, and go to years before, you can see all the hills at this natural state. But now you can see all of these hills with a lot of tree. It is
Right.
amazing.
It's obviously very economical. I mean, the economics is good, and so that's why they do it, I guess.
Yeah, and it is very strange because, well, all of these trees are located in hills, in the hill slope. But not only you need the water, but you need to pump the water to have a slope. So this is why the avocado here is expensive also.
Right. And Matthias, I really like your work. I think there's a lot of comparisons that can be done with the California Central Valley and in the Central Depression in Chile. And your work established a strong connection between the Andes and the mountain block and mountain sump recharge into the Central Depression. We're really I don't think we have a great handle on how much recharge the Central Valley gets from the Sierras in California. So can you describe the recharge sources to the aquifers in the Central Depression and how you were able to figure out what the recharge sources are?
Yes, well, when you see the Chilean territory, you can see that around 85% is composed of hard rock, mainly volcanic rock, intrusive rocks along all the Chilean territory. So you have the around 15% of alluvial deposit. And if we consider the traditional view of aquifer that just sedimentary deposits are aquifers, that in Chile was the main view until 2020, until 5 years ago. Well, this is why all the water rights are located in the valleys, in all these sedimentary deposits. But when you see the cordillera, the mountains, which is formerly considered as impervious or as a no-flow boundary, non-flow boundary condition, but when you see the mountain, you can see a lot of springs outflowing groundwater from volcanic rocks. So it is not consistent, this kind of model of the hard rock is an impervious. So we start this project with Linda Daniele and Benoit Guerre, that are both professors during the PhD. We start to study how groundwater circulate in the fracture media, in the volcanic rocks. And at the beginning was a little bit difficult because with this insight that the hard rock is impervious, we don't have wells in the mountain. So I had to walk a lot in the mountain to collect groundwater from the different springs. Sometimes I walk more than 14 hours to try to collect water samples from the peak of the mountain. But well, from this, we developed a new conceptual model to try to that explain the hydraulic connection between the volcanic rocks of the Andean Cordillera to the Central Valley alluvial aquifers. And well, from this, we can say that we have a mountain block recharge, mountain front recharge. Especially mountain block recharge is associated to geological faults that cross-cut the mountain front. So we have a kind of conduit or a kind of pipe, if we can say that connect the volcanic rocks with the alluvial deposit. This is the model that I try to explain. And well, now I am trying to investigate the different contribution from mountain, either mountain front or mountain block, but also other different recharge source, as for example, irrigation canal. So we are trying to quantify the different contribution from irrigation canal, from mountain block, with different geochemical tracers. This is the idea now because, well, the beginning, the idea it was to identify the recharge mechanisms. And now we are trying to quantify.
Well, that's fantastic. So you really changed the conceptual understanding of the system. I mean, if they thought, the central depression was just recharged in the central depression from rainfall that occurred there, and that there was a no-flow boundary with the mountains, but you've got this high precipitation in the mountains, and where's it going?
Indeed, we demonstrate that direct recharge from local precipitation does not contribute to recharge. It's mainly from the high mountain, so indirect recharge from the high mountain rivers, and another proportion from the mountain block recharge as inter-aquifer flow. These two mechanisms are the main important recharge mechanisms from the alluvial aquifers here. But direct recharge, I think that to the southern Chile, yes, contribute. But here, where we have 300 millimeters per year and groundwater level at around 100 meters depth, so it's a little bit difficult.
But also, so you have thrust faulting, I think, along the mountain front, but then you've got these cross-cutting faults then that you say provide pathways then for the water to get into the alluvial aquifer system. And then also in the central depression, you've got irrigation canals that leak. And so that's another recharge source, but also degrades the water quality some with the leakage from those canals.
Yes, indeed. We have these two main mechanisms. The irrigation canals comes from the high mountain rivers, distribute the water in the Central Valley. And this kind of water have a special chemistry. It's more sulfate and have some metals that are associated, for example, manganese, iron, nickel, associated to the porphyry copper from eugenic sources. So you can distinguish this kind of water from the one coming from the mountain block that is more associated to bicarbonate water and more dilute water with less metals. And yes, we have that. But where the agriculture usually use the irrigation canal, obviously. And well, with the irrigation, the quality of the water start to decrease associated with the nitrate input, for example. At least it was we see here in the central area of Chile, in different places in the San Felipe Aquifer, for example, that is my main study area, but also in another valleys like Catemo, for example, like in Rancagua, Chacabuco, etc. We have different study areas here. So we always find nitrate as a main anion up to, I don't know, 70 milligrams per liter, for example, in some aquifers.
So is that like 70 milligrams per liter as nitrogen? So the World Health Organization limit is 10. So it's like 7 times or is it 50 milligrams per liter as nitrate? I just want.
Yeah, it's a lot in some part.
Right.
The average is around 20 milligrams per liter in the alluvial aquifer.
Okay.
In the hard rock aquifer, in the volcanic rocks, we don't have too much nitrate. We don't have sources, so
right.
Yeah, it's less than 5 milligrams per liter.
And that's fantastic how you were able to use the chemistry then to identify the sources and figure out where water is coming from. And you mentioned coming from the mountains, then you have some iron and manganese high levels, and so you can distinguish that from the in the irrigation canals and all of these different sources. So good luck with quantifying the relative contribution of these different sources.
Thank you. Well, we have one PhD student, Renata, that is working with different isotopic tracer, strontium, for example. We're trying to work with sulfate to try to determine not also the sources, but also the mixing. So it is an, I think, that interesting project because we are working in an intermountainous alluvial aquifer. So it is a kind of natural laboratory that allow us to try to give another tools for this for the water management.
Right, right. And so, the mega drought or hyper drought, whatever you want to call it. Um,
Yes.
so I was looking at some papers and they were describing it, as this southern blob or, this southern Pacific pressure trend dipole and the southern blob and causing pressure ridging, and so the storm tracks are forced to move south. And so you're missing out on the storm tracks and they're going further south towards Antarctica. Do you know much about this, Matthias?
Oh, I am not so much expert, but well, the megalodon, well, since the beginning, the rain in Chile is usually controlled by the ENSO, El Niño Southern Oscillation. Yes, and during the El Niño we have the humid period, and during La Niña we have the dry period. But during the megadraw event or hyperdraw, it is uncorrelated with the ENSO. It is more associated with this kind of South Pacific pressure that, if I'm not mistaken, is coming from Australia or New Zealand, if I'm not mistaken. And it's more associated with this kind of climatic phenomenon. I don't understand too much, so I don't want to lie, but I can say that well, you can read the scientific articles of René Garreau, that is one of the a very big client geophysicist of atmospheric research. So uh, I know that he studied this phenomenon.
Right,
So
right. Yeah.
I can tell you that.
I did look at some of his papers. So you mentioned El Nino Southern Oscillation, and so being very important, and similar to the Southwest U.S., El Nino is generally associated with wet conditions and La Nina dry. But then in California, we see a lot of atmospheric rivers. When they make landfall, they oftentimes are doing drought busters, so they end these long-term droughts. And so in California, they had major atmospheric river events in 2017, in January, December 2016, and January 2017, and also in 2023. And prior to that, they had long-term droughts. So I was just wondering, does Chile see many atmospheric rivers?
Yes, and the last, I think, 3 years, we have a lot of events of atmospheric rivers that triggers landslide or this kind of geological dangerous things. I think that around 10 atmospheric rivers that impact in the central area of Chile and in the southern area with intense precipitation, and the rain, the amount is around the quantity that fall during all the year, but in 1 or 2 or 3 years. So it was a very intense event when occurred. And well, the people scared a little bit, especially the ones that are living in the mountain, because occur a lot of landslide. So it's difficult. It's a difficult event. Well, Chile is very known for this kind of event, for earthquake, for example, for for alluvions, etc. We have a lot of this kind of events, but every year are different, and every year we have to be prepared for this. It's a lot
Right.
of water, and we can say, okay, it's fantastic, but no, it's not so fantastic.
It's just too much.
Yeah.
But I mean, so basically, what you're saying is that you had the entire year of rainfall would fall in a couple of days, in a few days, and so very intense high rainfall. But in California now, you would try to capture that rainfall, and so they use forecast informed reservoir operations to store more water reservoirs and then put it into the depleted aquifers. So maybe with time, you'll be able to try to manage these extremes and try to use it to recharge the central depression aquifers with time.
Indeed, this is one of the idea that we have, but we have to try to form an interdisciplinary team to try to address this problem, because we as hydrogeologists, we have some point of view, but the civil engineer have another point of view that is very important because it's infrastructure. So we are talking about that to how to manage this kind of event. For example, a first idea is to open all the irrigation canals, for example, but it's not too easy because, well, you can generate some floods. So, well, we
Yeah.
have to talk to try to manage this event with the engineer.
Right. Yeah. And I agree, engineering is very important in the US. The US Army Corps of Engineers is very involved in trying to store more water and to change their regulations for their reservoirs to store it and then maybe recharge aquifers downstream. And they're doing some of that, like Prado Dam in California and others. So yes, connecting the infrastructure, the engineering, and the regulations with the opportunities to store it and stuff. So it takes a lot of time and effort coordinating all of these different groups.
Yes, and the problem in Chile is that we have a very fragment communication between the different governments. So we're trying.
Right. So, lastly, Matthias, the institute that you're working in, or the center, is doing work related to geothermal energy, and so one of the aspects oftentimes linked to water is, what is the main sources of energy and electricity, and you've got a lot of potential for hydropower, and you also have huge potential for geothermal energy because you're part of the Pacific Ring of Fire. So, but I see also you import fossil fuels from the US, and then I'm sure you have a lot of renewables now, wind and solar. So maybe you can describe that a little bit, Matthias.
Yes, well, I work in the Centro de Excelencia de Geotermia de los Andes. SEGA is the abbreviation. Well, this research center works from 2010 and end in 2022, around 2022, at least the funds. We are also working within this center as a name, as the spirit of this center, because at least for me, Sega made a lot of good things for Chile, particularly to try to give this notion of the geothermal energy, because in Chile, I think that in a lot of country occur, we try to see all the things that works over the land, but the geothermal is a kind of hidden energy, and when people talk about geothermic, the geothermic seems like just for electricity. But no, you can use the temperature of the aquifers, for example, the temperature of the subsurface in the Badal zone, and you can give a direct use for climatization, for example, especially during drought event with a lot of temperature in summer and cold winter, it is very useful. But people don't see too much that. And well, on another hand, it is the first version is a little bit expensive. You can recover this in 10 years, for example. But well, if uh, we see that geothermal is a little bit difficult to occur here in Chile. Most of people try to see the wind energy, the hydroelectric, and also the solar energy. But for example, well, we have the Atacama Desert, so we have a lot of sun and big radiation. But the thing is how to manage the solar energy plant, because today all these solar panels are being rubbish in the desert. Because well, in Spanish is chatarra, something that don't is not useful because nobody keep this kind of plant. So solar plant, if in a point of view, is easy, but during the time is being difficult to manage because it is trash in the desert. Uh, for another part, the wind energy, some people don't like too much because we have a very big infrastructure. Well, for me, it is a kind of touristic place in some areas because it is impressive to see these very big molinos. How do you say molinos in English? Miles, wine miles is
Oh,
the name.
mine's, yeah.
Yeah, yeah, because are very big. And well, if we see the hydroelectric, yes, in the high mountain rivers, we use this kind of electricity. Colbún, for example, is an hydroelectric plant located in central Chile, but in a southern city, and works very well. But well, if you ask me what I prefer, I think that I prefer the geothermal energy because it's stable during the year, it's located everywhere. Chile, particularly, is located in the fire ring, so we have an anomalous geothermal gradient. So I think that it is possible. So we have to need that the politic agree with that also.
So, Matthias, you wouldn't be biased because you are working for on geothermal research in your institute. I'm just kidding. But I mean, you mentioned the solar, and you said a lot of potential in the Atacama. So, do you have? I mean, the problem could be transmission. Then, do you have a grid system going all the way from the north to the central part of Chile? Do you have electricity transmission? Or is most of the electricity generated locally? Say for Santiago, you have hydroelectricity and you have some local solar and local wind. You're not transmitting electricity from north.
No,
Like,
indeed, it is transmitting
or
to a
is
lot
it?
of.
Oh,
Yeah, yes,
oh, okay.
indeed. Well, despite that, geothermal is not so sea is hiding, etc., and people don't take more attention about that. We have the first geothermal plant in South America that is Cerro Pabellón and contribute also to the energy in Chile.
Okay, great.
Yeah.
Well, groundwater is also hidden. We're used to being hidden, aren't we, Matthias?
Exactly, groundwater is very important in a lot of terms.
Right, right. Well, thank you so much, Matthias. Our guest today is Matías Taucare, and he's a professor at the Department of Geology at the University in Chile. And I really appreciate your educating us on about the background of Chile and also the water resource aspects. Thanks a lot.
No, thanks to you for this invitation. I really appreciate that, especially because I read all of your papers. So this invitation for me was wow, wonderful. So thank you. I try to do the best, and well,
Right.
when you want, I am here.